Hi, Mark Pesce here, author of Augmented Reality, Unboxing Tech's Next Big Thing. In December 2020, I gave a keynote speech at XRWA in which I explored many of the themes inside my book. So if you think you might be interested in the book, have a watch of the talk. It's about 30 minutes. And then, if you like, go buy my book. Thank you very much. Thank you, everyone. I wish I could be there in person. We all know the reason why. We all know the reasons why 2020 will not be like any other year. I have to say that it was an interesting experience to publish a book in the midst of a pandemic and get it through all of the steps. That's my new book, Augmented Reality. What we're going to do is we're going to talk about some of the questions that are posed in the book. The book is not really about the technology of augmented reality. We will discuss that to some degree, but it really asks us a set of questions that we need to answer as we're diving into a technology that will probably define the next 15 years in exactly the same way that the smartphone has already defined the last 14 years. But the roots of this book actually stretch back 30 years. It is exactly 30 years ago this month when I was on my Christmas holidays that I sat and read this copy of a book by William Gibson called Neuromancer. Now, Neuromancer is a fundamental text. It introduces the word cyberspace to the world. It introduces the idea of virtual reality as a massive network space. The term the Matrix, which of course got used in the movies, comes from this book. And so, in some sense, this book established a vision for what the future was going to be like. And I completely bought that vision. I read this book and I was like, I know what I want to be doing with my life. I was already a firmware engineer working in networking. I was like, let's kick this up a level. Let's actually try to make these devices, these cyberspace decks. And so what I did was I founded a company called Ono Sendai, which is the name of the company that makes the cyberspace decks in Neuromancer. We got Bill Gibson's permission. He was very gracious. And we started to work on what it would take in 1991 to develop consumer-level virtual reality. Consumer-level virtual reality costing less than $1,000. Most VR systems in 1991 cost north of $1 million. The reason for this was primarily a sensor problem. Virtual reality and augmented reality, at the end of the day, they're not really display technologies, they're sensor technologies. And there's going to be a lot of talk about what that actually means in practice in this talk. And so we knew that if we wanted to make cheap, affordable virtual reality, we had to solve the sensor problem. And so we did. This is the patent. This is a portion of the patent for what we called our sourceless orientation sensor. So this allows you to look around. It tracks yaw, pitch, and roll. And it does it for about $1. The nearest possible competing solution was about $100. So this was a fundamental enabling technology for consumer-grade virtual reality. And it came along just in time for a small company you won't have heard of called Sega to include in the design of their Sega Virtua VR headset. Now, I was involved in the design of this. And as you can see, the place just between the nose bridge, that's where our sensor sat in this design. So we designed the sensor. There was a market need for it. Now, this product was announced with great fanfare. It made the cover of Product of the Year for Popular Mechanics magazine. And then it was summarily and very quietly killed. And it wasn't until quite recently that Tom Kalinske, the CEO of Sega, announced the reason why. And the reason why is that when you try to generate a virtual world on an 8 megahertz, 68,000 microprocessor, what you get is something that's generally going to make the kids sick. And I was told privately that Sega was told by their attorneys that they were opening themselves up for the largest product liability lawsuit in history. So the integration of sensor data with the displays, which is at the core of virtual reality, has to be done in a way that is compatible with the body, or else the body is just going to kiss it goodbye. And of course, virtual reality went goodbye for basically around 20 years. My company, Ono Sendai, imploded, but that actually turned out to be a good thing because it imploded at just the moment the web was starting to take off, and that left me free to work with Tony Parisi to create VRML, the first 3D language for the web, which of course has now been superseded by WebGL. But it was the beginning of a networked VR that was browser-based and entirely open. So I've been thinking about the questions around augmented and virtual reality for 30 years. First thing I want to talk about, though, is a really fundamental question. What is augmented reality? And I don't want to answer this in the sense of a technological framework or presenting a set of devices. What I want to do is I want to talk about it as a series of operations, and these operations are communicative. So the two operations are A, binding metadata to a place, putting that data somewhere into the world where it is situated, where it is located. And then secondly, once that data has been located, rendering that metadata visible. Let me show you an example of something we've been doing for a very long time, which is a form of augmented reality, which shows you what I mean in practice. So this is a plaque on George Street in Sydney. It indicates when a church was built. It was built in 1840, so this plaque situates metadata on the building that reveals something about the building that the building does not intrinsically reveal in its fabric. And even more interestingly, there's actually metadata on the plaque indicating that the plaque was placed there 100 years later, so in other words, in 1940. So there's multiple layers of metadata that are situated on this building. We have been doing this. We've been building memorials for as long as you care to look back. All the way back to rock art. We are memorial makers. We have always been situating locative metadata. So we have always been augmenting reality in this way. And of course, the hope with augmented reality is that you'd be able to go somewhere like the Argyle Stores, which is one of the oldest buildings in the Rocks in Sydney, and doesn't really present much of its own history at its site. It's not really marked. There's a little bit of a marker on the building, but nothing that really tells you. At the same time, there's a great big article about it in Wikipedia. And so we have this idea that we have the entire world of human information that is not located, even though it's quite often locative, even though it's quite often information about a place, and that can be situated in a place, locatively inside of a building. So this is the fundamental operation that we think of behind augmented reality, the situation of data and then the reading of that data. Now, at this point in 2020, we have very few tools for either of them. But what we'll see over the next decade, and presumably with the help of all of your hard work, is a rapid evolution of tools to do both, which is why I don't want to get hung up on any particular definition of tools, but rather to take a look at this theoretically. All right. So if we go all the way back to the very beginning, this is Ivan Sutherland in The Sword of Damocles. This is billed as the first virtual reality system. It's actually the first augmented reality system because The Sword of Damocles was designed with half-silvered lenses so that what you would see was the 3D world that he created, which was very simple. And by the way, Ivan Sutherland not only invented the Sword of Damocles VR system, he invented real-time 3D computer graphics so that you'd have something to look through when you use the Sword of Damocles. So while you're using the Sword of Damocles system, you can see a 3D world overlaid on the real world. So the origins of virtual reality are actually in augmented reality. Now, if you take a look at the armature that's above his head, that's the sensor array that's actually working very hard in order to make sure that you can actually track the position and location of the head. Because it's in tracking the position and location of the head that you actually start to get the data feedback that allows that system to work as a cohesive whole. So the sensors are the key factor at the very beginning of this entire field. You go ahead 20 years and you get to the first practical modern virtual reality system, the NASA View system. Now, the basics here in terms of the displays, yes, they're higher quality displays, but they're still stuck in front of the face. The big difference here is that there's no physical armature anymore. Instead of an armature, what you have now is sensors. And I think in this case, they were Polymus magnetic sensors, so that it would sense the absolute position and orientation of an object in a volume of space. And this was an enabling technology, but a very expensive enabling technology. But again, the enabling technology here is a sensor-driven technology that's feeding, of course, now into a new generation of less expensive computers. Then you jump ahead about another 30 years, and you get to Pokemon Go. And now what you have is you have the sensor kit that has been reduced and also expanded into the smartphone. Because a smartphone is using not just its wideband networks, not just its internal compass, not just its internal accelerometer, but it's also using GPS, and it's using access to a World Wide Web, which simply wasn't, and none of this was possible in the 1980s. And so you now have this capacity to do cross-sensor integration. You have the smartphone camera, you have GPS, you have the net, and you bring these all together, and all of a sudden, as soon as you do this, you can now freely inscribe the real world with elements that are not native to that world, and you can do this in real time. So you start to get the first taste of what we're really starting to talk about as the operations of augmented reality. And then around the same time, you get Microsoft introducing its HoloLens. Now the HoloLens, rather than a smartphone, is in a sense completely self-contained. It produces its effective holograms using a technique known as simultaneous localization and mapping, or SLAM. And so the mechanism behind SLAM has become something that is a foundational technology in augmented reality. Let's take a look at the HoloLens. This is the HoloLens Model 1. Let's take a look at the number of cameras that it has. And it's using all of these cameras continuously, feeding a data stream into the processor on this device, which is both a processor and it's got a lot of hardware acceleration that Microsoft designed custom in here, in order to be doing the SLAM calculations and mapping the space and mapping the user's movement through space continuously. So what you have is this idea of a live, real-time data stream from sensors. So again, we come back to this idea that augmented reality is entirely sensor-driven, and that without these sensors, augmented reality doesn't work. From this, we get to the first big conclusion of my book, which is that augmented reality is fundamentally, inescapably, a technology of surveillance. Unless you use surveillance, augmented reality doesn't work. And now, a message from our sponsor. Project Panoptic is a research effort built around the custom glasses you see here that is designed to record high-quality, egocentric data, which will in turn enable researchers to advance the state of art around individual profiling and personalized, contextually aware ad targeting. Project Panoptic is not in itself an AR device, as it lacks a display, and is neither a product nor a prototype for a product, and will not be for sale. It is a research tool, and it is a critical step on the path toward a profile-driven interface to reality. One way to think about Project Panoptic is as an evolution of the methods that were used to build profiles in the past. For the last decade, detailed web-based surveillance has allowed us to map user behavior across billions of subjects. But it was limited by intermittent use. Even with infinite scrolling and intermittent rewards, even with increasing levels of engagement, those techniques eventually reach the limits of human attention. Only with a device that's worn constantly and used consistently can we fully capture the depth of interactions that can profile a user's behaviors. Project Panoptic is the vanguard of the next leap in user profiling technology. Client-based profiling will soon enable everyone with an AR device to feed a continuous stream of interactions back to our profiling servers, resulting in increased fidelity and improved ability to target users. The use of egocentric data will make it possible to construct detailed user profiles that are dynamically updated at much higher frequency, and will enable mapping of a far wider range of emotional states than has been possible with any previous surveillance technology. In addition to enabling state-of-the-art research into profiling, Project Panoptic will let researchers explore what data AR glasses will need to capture in actual use, and how we can most usefully leverage that data to generate personalized targeting. Let's take a look at each component in Project Panoptic in closer detail. At its heart, Project Panoptic is an all-day wearable computer and sensor platform with a powerful mobile-class processor, all wrapped up in ergonomic glasses in a form factor weighing not more than 70 grams. The device is controlled by a mobile companion app, which communicates via an encrypted low-energy Bluetooth link. Once a data stream has been recorded and the device is placed on charge, data is uploaded to our servers where our data scientists subject it to the latest techniques in behavioral analysis. Users give permission to upload their captured egocentric data, but we provide no transparency on how that data will be used once uploaded. The research version of Project Panoptic signals via LED when the device is recording. We expect that this feature will be removed when AR glasses go into mass production. Project Panoptic supports a variety of sensors that gather the sort of data that AR glasses will need to capture. These include a front-facing RGB camera, 2 side-facing monochrome cameras, and 2 inertial sensors. This combination of sensors allows us to both observe the environment and track the position of the user within the environment. In this example, we see the position and orientation of the user's head being calculated from sensor data as the user moves around their home. In addition to sensors that visually observe the world, Project Panoptic supports 7 directional microphones for spatialized audio capture and 2 inward-facing cameras to monitor and report on the wearer's gaze. Combining data from the inward-facing sensors with the position and orientation data of the glasses, we have a powerful tool that reveals what the user is actually interested in. The gaze reveals what the mind would hide. The combination of these powerful surveillance technologies with an always-on wearable form factor means that users can now continuously profile themselves, all of their interactions, and all of their close contacts within the environment. Project Panoptic has been developed to enable us to lean into these profiling and targeting opportunities long before AR glasses are commercially available. Starting this month, our employees will be required to use Project Panoptic devices in both public and private spaces, including their own homes, in order to inform the development of our surveillance and profiling technologies and further refine them. That's just a quick look at the capabilities that Project Panoptic brings to AR. I hope you now have a sense of why pervasive continual surveillance is the foundation of our business and the human future. So the thing that we probably need to keep front of mind is that augmented reality is a technology of many pieces. It is not just a display technology. It is not just a sensor technology. It is, and perhaps fundamentally, a technology of networked computing. That AR devices, at least the way we're designing them now, at least on the path that we seem to be headed, are in fact always connected to the cloud. And the thing that we've learned about the cloud is that the cloud has a mind of its own, and that mind seeks to shape our own. It seeks to shape our behavior. Now, I'm not trying to impugn any motives there. I'm just trying to point out the nature of that relationship. And if we're going to be taking exactly that relationship that we already have, and oh, by the way, that's the reason we're all addicted to our smartphones, because our smartphones are also coupled to that cloud, coupled to AIs, and coupled to systems that are feeding back things to increase our engagement. If we want to replicate that model with augmented reality, we simply need to do nothing at all, because that is the model that is being developed right now. But we have to wonder if that is in fact the model, if we want to take the mistakes of the past and simply re-implement them as the mistakes of the future. The one thing that is inescapable about augmented reality is that it is a complex dance of feedbacks between devices, human perception, and the cloud. And there is a teleology in the cloud, an intention in the cloud which cannot be separated from the effects of the device. But you know what? Let's just talk about art.
Let's talk about art. Now, with augmented reality, you're going to be able to create and discover all kinds of new art around your city. So, this is a piece at Facebook headquarters. And, without augmented reality, this actually just looks like a blank wall. But when you are in augmented reality, you get this beautiful piece of art that's not just a painting on the wall, but it fills up the whole space. And it's 3D, and not only that, it's something that would be impossible to build or make in reality, because you have this infinite waterfall of paint coming down, and it's really quite something to look at. Now, one thing that's kind of a funny side effect of this is that now we're on Facebook, we notice that there are just people gathering around looking at blank walls. So, this is going to be a thing in the future, right? I mean, it's just people just kind of sitting around and staring at blank walls. So we actually put a physical plaque on this wall to commemorate that we think this is going to be one of the first pieces of augmented reality street art in the world. But there's a lot more like this coming.
There's nothing quite as wonderful as a blank white wall. You can imagine anything you want there. If my book had two genesis points, one of them was in reading Neuromancer back in 1990, and the second one was when I watched Mark Zuckerberg give this talk at the F8 conference in 2017. It was when he said these lines that I experienced an insight. Because you can take any blank wall in the world and now freely inscribe it. And if that's a white wall, you can freely inscribe it with your art or your thoughts or your loves or your passions. But what if that wall is already inscribed? What if that wall is already dense with meaning? What if that wall is, say, the Grand Synagogue in Sydney, 150 years old and very proud on Elizabeth Street and the center of one of the oldest Jewish communities in Australia? And what if there are a bunch of people wearing their augmented reality spectacles or looking through their smartphones, or heaven knows what will happen in the future, and they're looking at that building? What are they seeing? Are they seeing a history of that building and the Jewish community? Are they reading biographies of the founders of that community who came together? Or are they looking at a spray-painted swastika? Because this is what you open the door to when you freely allow people to inscribe onto the world. And here we come to one of the central dilemmas of augmented reality, which I call the right to write. The fact that you can write somewhere does not, in fact, give you the right to write somewhere. And there's going to be contentions because the way we inscribe space changes the way we behave in space. Inscribing space signals to others, helps you find the others, helps you make your way. But there's no question that adding metadata to space changes the quality of that space. And don't I, as someone who might be a member of that synagogue, get to have a say on how that space is inscribed? Right now, the solutions for inscribing metadata in space are all primarily commercial. The three top ones, you've probably all heard of them. The one from Microsoft is called Azure Spatial Anchors. It's got a lot of very nice privacy features, but it doesn't really say anything about where or where you're not allowed to write in the world. Google's got AR Core Cloud Anchors, so similar, again, all in the Google Cloud, all using AR Core, so it works very well on all of the Android devices. And of course, Apple has ARKit location anchors. So all of these are commercial, privatized solutions which assert something that we almost didn't recognize, almost went past us. All of these solutions assert that the entirety of the real world is open to be inscribed on. That no matter where you go, you can drop your own metadata. You can cite your own metadata, and then you can come back and you can render that metadata, or anyone that you have nominated can render that metadata. If we do this, what we have done is we've essentially assigned a commercial right to these very large companies without any discussion about whether that's a good thing to do. We've probably violated the legal rights of the property holders who aren't even aware that they possess this right. But there's a bunch of case law that's starting to emerge because of Pokemon Go, which we'll come to, that actually shows that there is a definitive property right about inscribing data in space. This is not simply a free-for-all of the largest tech companies in the world. But if you look at the architectures and the APIs and the devices, this is exactly how it is being framed. And so all of these firms are essentially trying to encompass the metadata for the world on their own commercial platforms, whether or not they own a particular piece of property, whether or not they own any part of the world, whether or not they provided that data. And this is one of the other core dilemmas of augmented reality, which is how do we balance commercial interests with the rights of private property to allow space to be inscribed or not inscribed, because the right of silence is also the right to speak. And how do we do this in a way that is fair and compatible and open to everyone without any sort of commercial barrier? Now, I saw this problem a long time ago, and in 2016, just as augmented reality was starting to take off again, I put forward a specification for something I call the mixed reality service. And I'll step out of the way here so that you can actually see the slide in full. And you can go to mixedrealityservice.org. It's the beginning of a specification that basically creates a replication of the DNS layer. So DNS translates between names and numbers. MRS would translate between coordinates, located coordinates, and URIs, so that you'd be able to assign a pointer to metadata to any space. And the interesting thing about this is that when I put this to the Web 3D working group, all I got was pushback from a bunch of engineers who refused to understand that there was any reason to be bounded in their desire to be able to cite locative metadata anywhere. And we're still in this world where it seems very innocent to be able to do that. But we already know from the history of the internet, from the history of the last 30 years, that when you give someone a tool, you empower them. And you have to be very careful with that empowerment, because that empowerment can have all sorts of unintended consequences. And those unintended consequences will tend to persist. We can see this problem coming, so it is appropriate for us to start to think about a way to deal with it, whether it's MRS or something else. It's clearly something that needs to be open. It's clearly something that needs to recognize and honor individual property rights and the fact that any particular piece of property may be contested, that there may be many different stories and many different narratives that are competing to be heard, and that all of them, to some degree, deserve to be heard. So there are actually a lot of legal, but also cultural and social implications that appear immediately on the horizon, which are part of the AR dilemma. All right, let me illustrate with a story that I used to open my book. This is Peg Patterson Park in Rhodes. It's about 10 km outside of the Sydney CBD. It is a small park. It's basically a place that you can walk the dog and the children can get a play and a swing on the jungle gym. Not really big. Rhodes is one of those suburbs that's basically filled with tower high-rises, and there are tower high-rises on all sides of Peg Patterson Park, and Peg Patterson Park's just a small square in the midst of this. But on the night of Tuesday, the 13th of July, 2016, this happened. Let me explain what this is. You see, Pokemon Go was released in Australia 2 days before it was released everywhere else, because Niantic was taking their servers out for a spin to see if they could handle the load, and people started to play it. And it turns out, for reasons I'll come into for a minute, there was a Pokestop and a Pokegym in Peg Patterson Park. And at some point, someone came by while they were playing Pokemon Go, and they saw this. And they had to play, and then they messaged some friends who also came along and had to play. And one of them put down a Pokemon lore, so rare Pokemon started popping up. And then they told a couple of friends, and then they told a couple of friends. This is 11 p.m. on a weeknight at Peg Patterson Park, where it's become, well, not a riot, there's no fighting going on, but it's certainly become quite a crowd scene that appeared basically out of nowhere. And this video is being shot by a woman who lives above Peg Patterson Park, who is muttering about the fact that she and her kids can't get any sleep because all of a sudden, 1,500 people came out of nowhere to Peg Patterson Park to play Pokemon Go. Now, why did that happen? Well, Niantic had an earlier game called Ingress. And Ingress would cite its locations for its, basically, its capture the flag competition around locations that had public fixtures on them. Peg Patterson Park is one of those places. So Niantic had Peg Patterson Park in the database that it used in Pokemon Go. It just imported it. And so all of that happened quite naturally. It was just a single database import. The database represented the park there. And then what happened was an emergent process. And this tells us something that is fundamental, something we must never forget about augmented reality, which is that when you change space, when you inscribe space, whether it's with magical creatures or hate speech or anything else, you change human behavior. Changing space changes us. And it tips its hand because remember, this is basically the very first moment that augmented reality is deployed at scale anywhere in the world. And all of a sudden we get something that is completely unexpected. And that ends up with legal action being taken about Niantic, which then removes the Pokestops from Peg Patterson Park so that these folks can get some sleep at night. So we are dealing with a technology that is tampering with very fundamental forces and producing spectacular and spectacularly unplanned side effects. All right, how do you as creatives work in that world? I have 3 basic suggestions. First off, design thoughtfully. Think through the consequence of your actions. Think about how they will affect not just the people who are using them, but all of the people who are interacting with those who are using them. Think about what space means, who is using that space, who has a right to that space, why that space is speaking, and what that space has to say. Reflect continuously. Almost all of these systems will be intrinsically networked. They will be coupled to extremely powerful network systems. That means that these systems will have, as a basic design element, they will have an ability to express new patterns of behavior that could not have been intuited in their original design. They will be emergent. They will experience feedback effects. All of these designs will do that, which means you have to be looking at your designs continuously, you have to be understanding them, and you have to be adapting your design as these patterns emerge. And finally, most importantly, remember humanity. We have had a decade of systems design that tend to remove human agency, that tend to decrease the available choice and creativity for human beings. If we do that in augmented reality, we will take our existing problems and we will only amplify them. We do not want to do that. We don't want to be bearing the price for that. And we have a chance here to remember to design systems that express human agency, that increase our capability, that actually make us better and smarter, not just the drones of an information service. Thank you very much.